Hello, and welcome to episode 9, series 2 of Learn Synthesis with Pure Data. I'm your host, Dr. Lawrence W. Moore, and it's been almost 2 weeks since I released a video. I was affected by Hurricane Idalia, lost power for almost 2 weeks, but I'm back now. Lost some other things, but nothing that's irreplaceable. My wife and I made it through just fine. A lot of stress, but I'm ready to get back to it. So in any case, this episode is about a delay module. Throughout this series, we've been making like a granular synthesizer, virtual tape looper, ring modulation effect, and now we're going to do a delay effect. And all these things are basically being constructed as modules that can be loaded as abstractions into other PD patches. And this one will be the same. So let's take a look at how we can get some delay. Okay, so here's my screen. Just to show you, I've copied over all the modules that we've had so far. And then I took the ring modulation module, saved it to another name, basically copied it, saved as to delay underscore mono tilde.pd. And then I did the user interface, which you can see here. And I'm going to give you a tour of it now so you can see what it is I did. We have a little error right now because I don't have a receive made yet, but I will be making it, so don't worry about that error. But here we go. So from the ring modulation patch, basically I was able to just copy over the same view and the same size so things will work. The red outline indicates the viewable area that will graph on the parent patch when loaded as an abstraction. And here we go. We can actually right click and go to the properties. This is how you set it up. Basically you check off graph on parent here. And I also hide its title so that when this is loaded into another patch, you don't see the title up here in the corner. It just takes up space and it's not really pretty or anything. So its size is 240 pixels by 240 pixels. So that's its width and height. Margins are at 100, 100. That's basically how far from the top or the left your red square is going to appear, denoting what area is graphing on parent. So that's the size I went with. Fortunately, the sliders from the ring modulation were already in the right size. I kept the input slider and the output slider. And then I added 3 more that will be for this delay effect. Well, I just took some of the ones that existed and added them. All these sliders are, what is it? The width is 15 and their heights are 101. Could just be 100, that's fine. I did that in case I ever want to have the numbers displayed when you're doing a range of values of like 0 to 100. Including 0, that's technically 101 different values. And then when the actual number gets displayed somewhere, it'll be a nice, neat 2-digit, 0.2-digit number rather than a long a long floating point number. It just looks nicer. Don't know. I mean, I haven't added that yet, so that's not super important. But anyway, the sends and receives for input are here. $0 underscore input underscore send. Or hold on here. Let me make sure. Yeah. Input level. Okay. Input level send. Yep. So that's the name of that. I'm sure it's the same thing except output level over here for the output. These are both a range of 0 to 1, our amplitude values in PD. This is so you can measure how much signal is being allowed into here and then how much is being allowed out. They will eventually control the inputs that are coming in and out. I have the inlets here. The inlet, so when something connects to the inlet of this module from outside, it's sending an audio signal under the name $0_audio_input. The $zeros, remember, are there so that when this is loaded as an abstraction into another patch, a unique number is put in place of the $0. So you could actually have multiple of these delay effects in a larger patch, and they will coexist with each other without confusing each other with symbol names and so forth. And then the outlet here, basically I'm sending out the $0 audio output. Now, these have not been created yet in the patch, so I will be creating that. I haven't made the actual delay portion of it. This is all preliminary stuff set up. I made a slider for mix. Its range is 0 to 1, and it has send and receive symbols here. $0_mix_send. That's so you can mix how much of the signal is affected by delay and how much is dry, not affected by delay. And you'll see how that comes into play when I actually do the patching. Time. This is basically the delay time, or the time interval in between each instance of delay. So basically $0_delay time_send is its send. And this one is actually 0.01 up to 1. Basically, I don't want a delay time of 0. That would be no delay whatsoever if you had the slider all the way down. And I just don't really want to have that. I mean, I don't mind if the delay is close to something like a reverb or the repetitions of sound. And I'll be explaining this as I do the patching, but the repetitions of sound will be spaced apart by at least some sort of interval, and we'll see how that works out later. Right now, I'm basically using the range of 0 to 1 on everything except for this slider. The time delay is 0.01 up to 1. Now, that's not time in milliseconds just yet. That's going to happen later in the patching. But this just gives us almost like a percentage of how much of the maximum delay time we will have. And feedback is a range of 0 to 1. And we'll see how all these things work out in a moment. And I made an array here. Once again, if you haven't seen the other videos in this series, if you see them, all this is review, basically. You'll see how to make all this stuff and why I make things the way I do. So its name is $0_waveform, basically so we can see the delay happen, or at least see audio signal. We won't really see much showing us delay, but we'll at least be able to see the audio signal. Now here I have a subpatch, PD loading. This is what I've been putting in all my modules. This sends out the default values to start with. A load bang at the top, hitting a bang here. This bang is just here so that I could click this when I'm patching and setting up things, just to send the default values without having to close and reopen again. It's just a nice thing to have. And then it's a trigger bang, 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 bang. And the first bang turns on DSP. The second bang going right to left in the order that things are actually processed in pure data. I have the sample rate being calculated here. Actually, this patch is probably not going to use this at all. This was just a remainder from a previous, the ring modulation and so forth. But I'll leave it here. You never know, if I expand on this patch, add more things to it, I might need the sampling rate. It doesn't hurt when it starts for the sampling rate to actually, well, to be honest with you, since there's no receive for it, this would just cause an error to say there's no receive, no matching receive. So, yeah, maybe I'll take that out. There we go. It's not going to be used in the patch anyway, so why have it? All right, and then here we have a message of 0.5 being sent to these middle three sliders. Their default value will be 0.5 when the patch opens. I mean, it's up to you what default values you want to have set, but I think that gives us a nice little delay effect. As soon as the thing opens, you'll be hearing delay, and we're all good. Over here, I have the value 0.08 being sent to the input and output sliders. So to start with, they are at about 80% of the overall amplitude. And so that's good. That's the setup. So now we're going to make the actual delay itself. I'm going to make here a sub patch PD delay. So we could keep all the inner workings of the delay right inside here. So let me expand this out. Think that just might be big enough. Now, the way this is set up right now, because it's receiving input from an inlet, like the audio is meant to be coming through this inlet, we're not going to hear anything right now. But when we want to, we can easily just put in an ADC and a DAC just to test things as we go. But right now, what I want to do is put here the receive that corresponds to the send. Right here, the audio would come in through the inlet into the patch and get sent under this symbol name. So we're going to receive that. R tilde, receiving audio, $0 underscore audio underscore input underscore send. I believe, or no, it's just called audio underscore input. Yep, that's right. I only put the send at the end of things that are for graphic objects because they have sends and receives. But audio input is its own one thing. So there we go. So we receive our audio in here. Now we're going to have a wet dry mix to this, like this fader here that is our mix. So our dry mix would really be a straight line down to our output, which we might as well put here. We're going to send the audio signal out to $0 underscore audio underscore output. And that happens to be the audio output right here that goes out the outlet. So this module, and before the end I will put this in the modules patch so you can see it hooked up and so we can test it out actually. So now our audio signal coming in, we want to have a dry version of it, but we want to be able to control the level of this dry version. So I'm making a star tilde, basically an amplifier there for the audio signal coming in and the audio going out. Now, the way this is set up, since we're just working on this module directly and we don't have an ADC or audio input actually hooked up yet, just the sends and receives, we won't encounter this problem. But one thing is later on in this patch, you will want to use headphones, especially if you're using a laptop with a built-in mic and built-in speakers. You are going to get a lot of feedback from this unless you plug in some headphones. Basically, your mic should not be hearing the output from your speakers. So using headphones will eliminate that. This patch can be used in live performance, but in live performance, typically your mics are behind the speakers. So the speakers are facing the audience, the microphone's facing you behind the speakers, so they don't feed back unless things are just way too loud or something. So this would just be like, something that can be used in live performance or in the studio, but you just don't want your mic to be picking up your speakers because you will get feedback. Okay, so anyway, that's your warning. Now, what we want to do is measure and control the dry mix versus a wet mix. Now, the wet mix is going to be this. we're going to set up our delay feed right here with an object called del right tilde. Put a space. And then the next thing is a name for, it's like a symbol, just like the other things like sends and receives. The symbol for this audio signal that this delay is going to be called. So I'm going to call it $0, so it has a unique name, underscore del sig. How about that? Delay signal. And then after that, you put a space, and then you're going to put the maximum amount of time in milliseconds that your delay could be. Now, it's going to be adjustable, but we're going to put the maximum amount of time, so there's a certain buffer that PD establishes with this object that it will read this much of delay. It doesn't necessarily use all of it, but this is how much delay it will actually have space for. So I'm going to say something like 2 seconds, which is 2,000 milliseconds. Okay. And then we could hook up our audio signal to it. So our audio signal is going to here, as well as down here, where we'll control the wet and dry mix. But we haven't finished with the delay just yet. Now this del right can go to a del read, or it can go to something else that I prefer to use, and that's VD. VD tilde. And then we put in the name of the signal that's receiving. Basically, this is like a send over here, and this is a receive over here. And we're going to put in the name $0 underscore del sig. Now, we don't need to put in 2000 or anything here, because through its inlet, we can send what will actually be the delay time. Now, we have a slider back here, being covered up right now, but in the visual interface for this patch, we have a slider, and that slider for delay time is what we're going to want to receive here. So if I remember its send symbol correctly, we're going to receive just a regular R, because it's just control time data, and its name is $0 underscore delay time, all one word, underscore send, because the send from the slider goes out the send symbol, and so we're receiving from that send symbol. And the next thing we're going to do is pack this, because we want our change in numbers when we're changing our delay time, we want it to be smooth. Oops. So I'm going to make a pack F50. That means the F means floating point. Since this is a number coming in, that will take this place here of the F. So our delay time comes in, and over 50 milliseconds, it will go to whatever the new value is as new values come in, using the line tilde object. So this converts it to an audio rate and gives a 50-second ramp to every new value. That will smooth, 50 millisecond ramp to every new value, and that will smooth it out so you don't hear little snaps, little artifacts happening. Okay, so this is where it's receiving the delay time. The signal's coming here with its with space for up to 2,000 milliseconds of delay, and then here it'll receive. Forgot one thing in the middle here. Remember, this slider is a range of 0.01 up to 1. So we're going to multiply it by the max possible delay time times 2,000. So that way the resulting number, like if it's up halfway, as it is by default, it'll be 1,000 milliseconds that will be coming through, and that will be our delay time. Now this is our delay signal right here. We're going to give it its own star tilde to go through. Right there. Now, we're going to have it go in here. And so this is our wet signal right here. This is our here's our wet signal being sent to over here, and this is actually it. In fact, maybe just to make it look a little more organized, I'm going to move this down and put this above it to show that this is all the delay side, and this is the dry side over here. Now, what we're going to do is these two signals will eventually be combined. So I am going to put a plus tilde here so that our delay side and our non-delay side, our dry side, will both be added together. There we go. Now we need to be able to mix the wet and dry for how much delay is on the signal. That we can do here by having receive $0 underscore mix underscore send. That comes from the mix slider. And basically 0 to 1 is its range. 0 at the bottom, 1 at the top. So I'd like that to be how much delay is happening. So when it's up to 1, it should be full delay. When it's down to 0, it should be none. So what I'm going to do is we're going to have here our good old swap 1 here. And then we're going to make an object under that that's a subtractor. This is our good old inversion. I've been using this a lot anytime values need to be inverted. A range of 0 to 1 gets inverted by subtracting 1 from that range. So when this is at 1 coming in, this will convert that to 1 minus 1, which is 0. And if it's at 0.5, 1 minus 0.5 equals 0.5, and so forth. So this is the inversion of this. Like basically, if we take this directly over here, we'll get its inversion. What I'm going to do is copy my pack F50 in line, because levels like this are things that you want to be smooth. And otherwise, it jumps from number to number. And this smooths it out so you don't hear those jumps, you don't hear the snaps. Hook it up there, that controls the level of our dry. And then we're going to copy this again. And take this here without inverting it, and this will be the level of our wet. And this will control its amplifier over here. Now, as this stands, we're getting one delayed signal. Basically, when sound comes in, when it goes here to the delay side, it's getting delayed by however many milliseconds are being defined by your slider here. And so you're going to get one, in other words. If you just want one slapback, then that's fine. That's what you're going to get. But delays, a lot of time, are best with some repetition. And basically what we're going to do, those repetitions are often called feedback. So we're going to receive from a feedback slider we have out there, $0 underscore feedback underscore send. And this is going to go into a pack F50 and a line tilde. And what we're going to do is take our star tilde here. This is going to go in the right side. And the left side is going to receive our delayed signal. So this here, using the feedback slider on the outside, is going to control the level of the delay as it goes out to be sent back through itself again. That's where you get like a clap sound. You hear, you get the clap come through once, it gets attenuated here, reduced, comes back through again, and so forth. And so that's what this mechanism is going to be. Just hold on one moment, please. I need a pause. Okay, and so I'm back. What we're going to do is send our feedback here. I'm just going to make a send tilde. And we're just going to simply call it $0. How about feedback sig? Okay. So we need to make a receive for it, and where we're going to receive it is right here, where it goes back in through the delay line again. And so I'm going to go send tilde $0 underscore feedback sig. There we go. I had made a send instead of a receive. Silly me. There we go. And so this receive goes right into here where it goes through the whole thing again. But each time the feedback, yeah, I'm trying to just move you over. Do you mind? Why? It really doesn't want to move. I have it selected, maybe the arrow keys. Yeah. Like select it and arrow keys. Down arrow. There you go. There, got it. Who needs a mouse? All right, so each time it comes back through, though, it's going to be attenuated by whatever level you have the feedback slider at. So that way, as you feed repetitions through, or instances of delay, they get quieter and quieter as they go through the loop. All right, so now we are ready to try this out. I am going to save it, close, save here, close, and even close the PD file. And I'm going to open up modules. This is where we test out all the modules that we make. And what we have here is our tape looper module from last time. What we can do is utilize it for the delay. Now, if I were to take this out and hook the ADC and the DAC up to it, ADC to the inlet of the delay module and DAC to the outlet, it would work. But once again, you gotta want to have headphones on for that, because your input is going to your output, even though delay may be added to it. You know, if your microphone's picking up that output from the speakers, you're going to hear feedback. But in this case, you wouldn't, because we're going to record to this thing and play back from this thing. So the live input is not going straight through to the output. So let's just delete this DAC here. And then I'm going to type into the object delay underscore mono tilde, which is its file name without the PD extension right there. There we go. And so it loads it right in. We hook it up there. And then we can hook up a DAC. Because we have these modules that I will continue to build upon in the future, making a modular system of all sorts of interesting synthesis components and effects. I think I will be in the next episode making an input and an output module. And it'd be nice to make an output module that not only gives you some more controls of your output of the signal, but allows you to record to file as well. And so, in any case, now one thing I've noticed here is our sliders are not at the 0.5 I intended them to be at by default. So I'm going to open up here. Here's our loading. $0.5 is being sent to $0_mix_receive. RECV. Well, hold on here. I can see it right over here. Oh, wait a minute. 2 of them are up, 1 of them's down. So mix is not getting it. Let me just retype in case there was a typo. $0_mix_RECV. Okay, now let's hit this. Obviously, I have a typo in the slider here. Aha! That's not a $sign. There we go. Okay, now we can test it out here. Now, I could have sworn, though, in here, now it's at 0.8. What? Okay, what happened there? Its range must be off because I just sent it a 0.5. Let's see, its range is 0.01 up to 1. The mix actually should be 0 to 1. Is something else sending to this? There we go. Let's see here. Here, 0.8 is being sent to output level receive and input level receive. And let's send that again. Is something funky with this slider? Yeah, because even though the range is 0.01, that's close enough to 0 that 0.5 should look like halfway up. Are we on, oh, we're on logarithmic? I don't know how that happened. But yeah, we should be on linear. I don't know, that must have been accidentally tapped by me at some point. But yeah, you want linear on all of these sliders. There we go. So anyway, all part of debugging. Now let me record some test audio for this delay effect. And I'm going to put on the loop here so it keeps playing it back and forth. Now let me record some test audio delay effect for this delay. Now let me record some test audio delay effect. Now let me record some test audio for this delay effect. Now let me record. See, when I turn the mix all the way down, now we're hearing dry, undelayed audio. But as I turn it up, we'll hear more and more delay. Some test audio for this delay effect. Now let me record some test audio for this delay effect. Now let me record some test audio delay effect for this delay. Now let me record. Now let me record some test audio for this delay effect. Now let me record. Now let me record. Now let me record. Now let me record. Yep, stop it. All right. The next thing is this feedback controls how many repetitions we get. Basically, because the higher it is, the stronger their amplitude will be. The lower it is, the weaker their amplitude will be. So the sooner they get attenuated out of the sound. So let's do that. Test audio, test audio, for this delay effect. Let me record some. Now let me record some test audio for this delay effect. Let me record some. Now let me record some test audio for this delay effect. Let me record some. Now let me record some test audio for this delay effect. Let me record some. Now let me record some test audio for this delay effect. Let me record some. Now let me record some test audio for this delay effect. I have it pretty low there. Now the first delay is going to be stronger, and then over time it should get weaker. Let me open this up though. I have a feeling it should be, yeah, it's a range of 0 to 1. That's correct. Maybe because the mix is a little high, I don't know. But I would figure those iterations would have been faded out sooner. Now let me record some audio for this delay effect. Now let me record some test audio for this delay effect. Yeah, actually the thing that's confusing me is because I have this looping. I'm hearing the dry signal come back pretty frequently, and it's easy to confuse that with a delay. Let's hook this up directly. And remember, if you're going to do this, you want to have headphones on right now. Okay. And let's have it come out both sides. There. Okay. Damn it. Let's turn this off here. Oh no, it's still the output. Oh, I didn't hook these up. Okay, let me just turn off. There, I turned off DSP so you don't hear two of me. Yeah, I didn't put the input and output on the signal at all, so I got to do that. But as you heard from that time with the feedback down and without the virtual tape looper, you hear me kind of disappear pretty soon. So let me turn that back on so you can hear it again. Let's turn off. Hello? 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 So there you go. You see, I can basically, this controls basically the amount of repetitions. How much of a feedback loop do you have? How strong is it? How soon is it going to just fade away because it's being attenuated more? And then delay time. Like this is the time interval in between the different instances of delay. So I'll have to turn up the feedback a little bit, and then I'll raise and lower this. So let's turn back on DSP. There we are. Boing, boing, boing. Ding, 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 ding. Da da da. Da 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 So yeah, that is basically the amount of time interval. It's basically a range of 0.01 up to 1 being multiplied by 2,000. Basically, the max would be 2,000. If I had this all the way up, it'd be 2 seconds worth of delay between each instance of the repetition. So yeah, that's how it goes. What I need to do now is add the input and output sliders so that I can control the level coming in and the level going out of the module itself. So we open it up, and I think their names are output level and input level, all one word. Okay, good. So we just go in here to delay, open it up. Here's our output down here. both the wet and the dry. Come on, man. There we go. Pull you down. Pull this down a little bit because we need to put one for the input above. Now, once again, we're going to want the pack F50 and line tilde on this. So we put here receive $0 underscore audio. No, it's called output level. Output level underscore send. That goes to a pack. Come on, type right. Pack F50 and into a line tilde. All right, and that will go into another star tilde right here. So the left side, the signal goes in here, out here, please. Okay. And our line tilde goes in here like that. I usually like to make it look a little nicer like that. Now I can copy this or duplicate it, Control D, Command D in Mac. Bring you up here. Disconnect these two and make another star tilde right about here. Where this comes into it on the left side and this comes into it on the right. Now we do need to rename this. I just was saving time by using this one, but this is actually going to be the input level. Send right there. That controls the level coming into the module. And then we're going to hook this to the outlet, the dry side. And then we need to hook this up to the wet side. It goes into del right there. Okay. Move all this down a little bit. When it's at an angle, it's easier to see where things are plugged into. Although there's only one outlet here and one inlet here. So there we go. Now we have our input and output levels set up. Save this here. And then basically, I'm going to turn on DSP again. Hello. Hello. Oh, because I just set those up, I need to move these sliders to, to get input and then output. Input and then output. Input and then output. Input and then output. Turn that down, and I'm no longer coming into the module. I just hear the delay that was already in there. I could just flick it up, flick it up. Yeah, and then keep talking, and it doesn't go through. Basically, you could control how much of a level is coming in. And then how much of a level is coming out. You want to mute things real quick, just turn it down. There you go. Now these sliders are steady on click. You could set these to jump on click, 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 jump on which allows you to just click on the slider and put it to wherever you want. Slider, just click on the 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 slider. So anyway, let me turn that off. Okay, so there we go. We got a delay module to add to our other things. One thing I've noticed is I am going to make improved versions of these. This is a tutorial series showing people how to do it, but I'm probably going to have a standard for maybe a little bit taller modules or something, and make them look a little bit nicer and stuff than they are right now, but at least people see how to make them. And that'll be in Series 3, where basically I'll be releasing, each video will be a new module. And a lot of them will be based on these, just maybe refined, and I just take you on a tour through it rather than making it with you. Because after 2 seasons of making it with you, people that go through these first 2 series will probably be ready to just kind of like, not just follow the leader, but basically look at patches and analyze them and understand them better, especially when I'm giving you a tour. So that's kind of like the plan for the future. But in any case, it's great to be back. Let me do this. I want to add this virtual tape looper before we go. What's its actual file name? Tape_looper_mono tilde. So anyway, that turned DSP on again. But now the ADC is hooked up to it. So the only sound that will come through the delay will be from the tape looper. Up, but up, but up, 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 but up, da da. Up. There we go. Turned off DSP. We're good to go, baby. We got a delay effect, and that adds to our arsenal. Thank you for joining me, and until next time, stay free and take care.